So let's see eigenfunctions of Lz and L square. So in this we are going to derive eigenfunction of Lz and L square. So for a as we know, for a given single value of L, that is suppose L value is 2, that is if azimuthal quantum number L is 2. So then we have 5 possible m values, that is 2l plus 1, 2 into 2 plus 1, 4 plus 1, 5, that is minus 2, minus 1, 0, 1, 2, like that. So Lz has eigenvalue mh cut and L square L into L plus 1 h cut square. So here for a given L value we have many m values. So based on that, nearly the eigenfunctions of L square and Lz are the same. Of course, for different values of m, we are going to derive the eigenfunctions, but all these eigenfunctions would also belong to L square, because for a given single value of L, we have many m values. So because of that reason, so all these eigenfunctions would also be the eigenfunctions of L square. So now let's see the derivation of these eigenfunctions. So the generating procedure terminates if one or two values of m exist, so this point has already been discussed in deriving eigenvalue of L square, also in even in generating eigenfunctions, generation of eigenfunctions, that topic also. So generation of eigenfunctions of Lz and L square, in that point at that in that also this point these equations had been discussed. So we would have certain for a given L value is equals to 2, the possible maximum possible m value is 2 and minimum possible m value is minus 2. So beyond that it cannot go to plus 3 plus 4 plus 5 and minus 3 minus 4 minus 5, like that. So at that time the wave function does not exist, generating procedure would stop. So that is the meaning of this. So the generating procedure terminates if one or more values or not two values of m exists at that. So this is for a maximum possible value of m. So at this point if we have already reached 2, we cannot have 2 plus 1 for given value L is equals to 2. 3 we cannot have. So at that point this is the equation. So Lx plus ILy into Zl is equals to 0, and from minus 2 we cannot go to minus 3, that is minus 2 minus 1 minus 3, because the values of m ranges from minus 2 to plus 2 only. So at that point this is the thing. So yeah, for a minimum negative value of m, so Lx minus ILy into Zl dash equals to 0. So these are the two equations. So here L should be maximum and L dash the minimum value of m. So here it is already set. So this is for maximum values because we are having Lx plus ILy. So by 1 the value goes on increasing. So m plus 1, 1 plus 1, 2 plus 1, like that. So here L is the maximum value of m and L dash is the minimum value of m, xi of L dash. So next thing is, if we obtain a single eigenfunction of these two operators, then all other eigenfunctions corresponding to the same value of L square can be obtained by repeated applications of the operators Lx plus ILy and Lx minus ILy. So here it is said. So if we obtain a single eigenfunction of these two operators, so for these two operators, if we obtain a single wave function, so if one single wave function if we obtain, then all other eigenfunctions corresponding to same value of L square. So as it is discussed, for a given value of L we have many different value of m's, so that's why it is mentioned here. So then all other eigenfunctions corresponding to same value of L square. So for a given value of m equals to 2 eigenfunction, for a given value of m equals to 1 eigenfunction, for a given value of m equals to 0 eigenfunction. So like that can be obtained by repeated application of operators Lx plus ILy and Lx minus ILy. So we can go from lower -2 to +2 like that, or +2 to -2 like that. With the help of these operators, we can find another eigenfunctions also. So the first eigenfunction corresponding to m equals to L can be obtained from the condition that, so first eigenfunction corresponding to maximum value of L, if we consider, so here L is maximum value of m. So we cannot have m plus 1, that is 2. For L equals to 2, m equals to 2 is the maximum value. So we cannot have 2 plus 1, 3. So like that. So Lx plus ILy xi L equals to 0. This is m values. Regarding m value, this is. As we have taken m value equals to L, so it is L. So in terms of theta and phi, we can express Lx plus ILy as follows. So Lx plus ILy can be written as this: h cut into e power I phi into dou by dou theta plus I cot theta dou by dou phi. That is based on these values. Here we are having Lx in terms of polar coordinates. So actually we are to find Lx plus ILy. So in the place of Lx we need to substitute this, and in the place of Ly we need to substitute this. So if we see here Lx plus ILy, Lx in ILy, so this one must be multiplied with I. So if it is multiplied, already one I is there, so I into I square minus 1. So minus into minus plus. So what we would have, so this is also dou by dou theta, this is also dou by dou theta. So if we take it common, and h cut also if we take common, here already minus 1 we have got, minus into minus plus. So cos theta plus I sin phi, here I is there, I sin phi. So we would have e power I phi. In the same manner here also, I square is nothing but minus 1. So here we would have minus 1. Minus into plus minus. So minus 1 again can be written as I square. So in that I square, if we take common, that is minus 1 can be written as plus I square. If we take I common, so here also if we take I common. So here what we are having, cot theta, here also cot theta, here dou by dou phi, here also dou by dou phi, here I is taken as common. So we would have cos phi. Here 2 i's are there, I square. So if we take 1 I common, we would have I sin phi. So cos phi plus I sin phi, that is nothing but e power I phi into I cot theta. So hence we are having Lx plus ILy as h cut into e power I phi dou by dou theta into I cot theta dou by dou phi. Based on the polar coordinates representation, we would have this spherical polar coordinates. So we would have this term, this equation. Now substituting in equation 2. So this third equation has to be substituted in this equation 2. So in the place of Lx plus ILy, we need to substitute this term. So h cut e power I phi over here. So dou by dou theta I cot theta dou by dou phi into xi L equals to 0. So this is the term. And we already know that Lz is nothing but minus I h cut dou by dou phi. So if we operate this on this xi L, that is minus I h cut dou by dou phi xi L. So Lz operator operating on this wave function would give us the same wave function multiplied with its eigenvalue. Here eigenvalue is of Lz is nothing but m h cut. So in the place of m we are having L. So L h cut xi L. So after operating Lz operator on wave function, same wave function with its eigenvalue m h cut, that is L h cut. So we would have Lz xi L h cut xi L. And next thing is, so here in this equation we need to send this e power I phi to that side. So 0 by e power I phi is nothing but 0. Next what we have to do is, what would remain is h cut dou by dou theta. So h cut dou by dou theta xi L. So that has to be kept aside, and we need to send this term to that side after multiplying. First we need to send this term to that side. So h cut into I h cut cot theta dou by dou phi, cot theta dou by dou phi xi L. So here it is getting added. So if we send it to that side, it would become minus. So that's why we are having minus. So this equation, the same equation is modified in this manner. After modification, we would have this. And next thing is, as we already know, here minus I h cut dou by dou phi, minus I h cut dou by dou phi is nothing but L h cut xi L. So we would have here L H cut xi L L. So except cot, if we take cot theta aside, minus I H cut dou by dou phi xi L L. So that is nothing but L H cut xi L L, L H cut xi L L, cot theta if we keep aside after simplification. And next thing is, here already H cut is there, here also H cut is there. So just get cancelled. So dou xi L L by dou theta. L cot theta xi L L, L cot theta xi L L. And next thing is, cot theta is nothing but cos theta by sin theta. So here cos theta by sin theta we will be having. And next we need to send this dou theta to that side. Dou theta here, and this xi L L to this side. So here it is getting multiplied. Here if we take it, it would be divided. Here it is getting divided. If we send it to the side, it would get multiplied. So this is the thing. And if we do integration in the next step, integrating on both sides. So integration of dou xi L L by xi L L. That is nothing but it is of the form integration of 1 by x dx. That is nothing but log x. Hence we would have log xi L L. Integrating on both sides, log xi L L. And next thing is, here also it is of the form L into 1 by sin theta. Differentiation of sin theta is nothing but cos theta d theta. So it is of the form integration of 1 by x dx. So in the place of x we are having sin theta, in the place of dx we are having cos theta into d theta. So dou theta, if we integrate after integration, ln sin theta. So L ln sin theta, and this is a constant of integration. This is a constant of integration plus k of phi. And we know that log of a power b can be written as b log a. So if we follow the inverse formula, that is b log a is equals to a log of a power b. So here also we will have log of sin theta is there. So if we send to L, if we take L inside the logarithm, we would have sin theta whole power L. So here also log is there, here also log is there, but here only constant is there. So this constant can be written as log of g phi. So k phi could be written as log of g phi. Then finally we would have log of xi L L equals to log of sin power L plus log of g phi. So here log of AB is nothing but log A plus log B. So here log, here also log. So if we take it aside, so log of sin power L g phi. Here log of xi L L. So it can, if we cancel logarithm on both sides, we would have xi L L is equal to z phi sin theta whole power L. So after applying simplification procedures, logarithmic formulas, we would have this. So here it is given. So log of xi L we would have. So after sending this to this side and this, writing this as log of g phi, and this is log a plus log b. That is anyway log of ab. So left I will getting log of this. So finally we would have xi L L as this. So where g of phi is an arbitrary function of phi, it must be chosen to make psi L L an eigenfunction of Lz with eigenvalue LH cut. So this is some arbitrary function of phi. So it depends on only phi. So this here it is depending on theta. So this would depend only on phi. So it is an arbitrary function, and we have to choose that arbitrary function in such a manner that it would make this wave function an eigenfunction of Lz and with an eigenvalue LH cut. So in such a manner we need to decide this g of phi. What could be this what could be the value form of g of phi such that this wave function is an eigenfunction of Lz operator with eigenvalue LH cut. In such a manner we need to design this g of phi. So this means that g of phi is equal to e power IL phi. So g of phi is nothing but e power IL phi. So this is the only possible case. Now here if we operate this with Lz operator, we would get LH cut as this eigenfunction. How means? Known as IH cut dou by dou phi. We operate that. That is known as IH cut dou by dou phi xi L L. That is nothing but minus IH cut dou by dou phi, dou by dou phi xl. So differentiating this term with respect to phi if we do, so here sin of theta power l is not depending on phi, so it is remain as this is partial integration taken as constant. And if we differentiate this one, we would have it is of the form e power ax. Differentiation of e power ax is nothing but a e power ax, that is il e power il phi. So here if we see, so here il here minus I h cut, I into I is nothing but minus, minus 1, minus into minus is nothing but plus. So l h cut, we would have l h cut sin theta whole power l e power il phi. So this is again this same wave function. So again we would get the same wave function multiplied with its eigenvalue l h cut. Hence we have taken g of phi of the form e power il phi. So this is the reason this equation has been turned to this equation. So that is the thing. And next thing, so in order to obtain value of xi l m corresponding to smaller values of m, we must operate with lx minus ily. We can obtain. So next, from this, so from higher value, so for l is goes to higher value of m is 2. From that 2 to, if we want to go to 1, that we have to do 2 minus 1, 1, and 1 minus 1, 0, and 0 minus 1 minus 1, and minus 1 minus 1 minus 2. Like that, we it is possible only if we have this operator lx minus ily. So this is the eigen function for m value is goes to l, that is high maximum possible value of m. So for remaining values eigen function, if we want, means we need to just operate this lx minus ily, and this lx minus ily is like of the form like this. So just we have found out lx plus ily by using those conversions. In the same manner, minus lx minus ily is of this form. So minus, if we do calculations, proper calculations based on the spherical forms of lx and ly, so minus of lx minus ily is nothing but h cut e power minus I phi dou by dou theta minus I cot theta dou by dou phi. This is the relation we used to get, and with the aid of the relation, that is minus I h cut dou by dou phi, if we operate on the wave function, we would have l h cut psi l l. So if we cancel those h cuts, we would have this form. So here also the same, here also we are having minus I dou by dou phi. So in the place of this, in the previous section also we have done this, we have done this simplification, l h cut psi l l. So cot theta is being replaced with l h cut like that. So same procedure we need to follow here also, in this step also. So this minus I dou by dou phi is replaced with l plus l. So minus I dou by dou phi cot theta is nothing but plus l cot theta dou by dou theta plus l cot theta psi l l. So from the relation, so and from another relation, that is dou by dou theta plus l cos theta into psi l l is equals to 1 by sin theta whole power l dou by dou theta sin theta whole power l psi l l. So that is if we do simplification of this, so if we differentiate this both with respect to theta, so it is of the uv form, that is we would have vdu plus udv. So if we keep this sin theta whole power l aside, so this is equal to dou by dou theta psi l l plus, if we keep psi l l aside, dou by dou theta into sin theta whole power l, that is nothing but d by dt of x power n. So that is n into x power n minus 1. So that is l into sin theta whole power l minus 1, that is sin theta whole power l minus 1, and again differentiating with respect to theta, and differentiation of sin theta is cos theta. So now if we multiply and divide with sin theta here into sin theta by sin theta, So this sine theta would be consumed here. So sin, again we would have sine theta whole power L, because here L minus 1 is there, here 1 is there. So sine theta whole power L could be taken as common overall. If we see, so dou by dou theta xi L L we would have, plus xi L L L cos theta. So as this new sine theta in the numerator is consumed in this, so we would have cos theta by sine theta. Cos theta by sine theta is nothing but cot theta. So xi L L cot theta. So if we send this sine theta whole power L to this side, so we would have 1 by sine theta whole power L dou by dou theta sine theta whole power L xi L L, that is nothing but dou by dou theta is equal to xi L in plus L cot theta into xi L of L, like that. Hence we would have this. So if we do simplification of this, we would have this. After actually here this is cot theta. So this is the simplification procedure. So here we are having this term dou by dou theta plus L cot theta into xi L L. So this has to be replaced with this term. This term has to be replaced with this term. So we have started by simplifying this term, we would have this. So this has to be replaced with this term in this equation. So here we get neglecting factors of h squared minus will be observed in the normalization coefficient. So in this equation if we substitute, so here if Lx minus ILy is operating on this wave function, it would reduce the value of m by 1. So this is m value. So initially it is L at the starting. So L minus 1, we would have L minus 1 xi L. So here minus would be there, here h cut would be there. So all those has to be consumed in constants, normalization coefficient. If it is consumed, if we neglect that one, if we consume that in normalization coefficients, so if we neglect that, so what would remain is here 1 by sine theta whole power L as usual. It is here we are substituting. So here h cut is there. So on the left hand side of this equation we would have this xi L whole power L minus 1, L value reduced by m, that is m value reduced by 1. And in the right hand side h cut and minus are consumed, and in the place of this we have substituted with this. So we would have 1 by sine theta whole power L as usual, and dou by dou theta sine theta whole power L, and xi L of L is nothing but this e power IL phi sine theta whole power L. We need to substitute that. So here already one sine theta whole power L is there. So another one sine theta whole power L. So sine theta power L into sine theta power L is nothing but sine theta whole power 2L. And here e power IL phi is there. But here you are differentiating with respect to theta. So it has to be taken out. So e power IL phi. And already here e power minus I phi is there. E power minus I phi. In this, so actually we are simplifying this equation. This simplification is this, and this simplification is this. So in the place of xi L, this term we have substituted with this term, and in the place of xi L we need to substitute this term. So after simplification we would have this. So here we are getting e power IL phi from xi L, and already here e power minus I phi is there. So e power IL phi and e power minus I phi would put together, we would have e power I into L minus 1 phi. So this is the simplification procedure, and this is another wave function for m value L minus 1. So this is the wave function for m value is equals to L, and this is for m value L minus 1, another wave function. Now again, to obtain xi L L minus 2, we know that. So what we have to do in order to get xi L L minus 2 is, again we need to operate with Lx minus ILy. Again we need to follow the same procedure, operating with Lx minus ILy on both sides we have to do. So here Lx minus ILy getting operated on this wave function, and that is nothing but e power minus I phi dou by dou theta plus L minus 1 cot theta xi L power L minus 1. So from this equation, so in the place of xi L L we are having xi L L minus 1. So just replace it. So e power minus I phi, e power minus I phi. So h cut has to be taken in normalization constant, and here dou by dou theta, here also dou by dou theta. So in the place of L, here we are having ZL L. So here in the place of M we are having L. So here also L. But here we are having L minus 1. So hence in the place of L we have L minus 1. And cot theta and ZL L minus 1. So from this equation we would have this equation from this form. And here we have neglected this h cut and minus. We have taken it into the normalization coefficient. So finally we would have this. After getting operating this operator on this equation, we would have equation of this form. And again in the place of this we have to replace with this term, same as this, the procedure which we have followed. So this term has been replaced with this term. Here also this entire term is replaced with this term. So in the place of here we are having L, ZL L. Here we are having ZL L minus 1. So in the place of L minus 1. So 1 by sin theta L, 1 by sin theta power L minus 1. So keeping this e power minus I5 aside. So dou by dou theta sin theta whole power L, sin theta whole power L minus 1. And ZL L minus 1. Based on this formula, again we are going to repeat the same thing. So and after operating this operator on this wave function, it would reduce the value of m by 1. So here already L minus 1 is there. So L minus 1 is nothing but ZL L minus 2. So this is another wave function. And here as usual 1 by sin theta whole power L minus 1. And here we are having e power minus I5. So from here we would have, so ZL power L minus 1 is nothing but e power IL minus 1 5 sin theta whole power L minus 1. Just we need to replace L with L minus 1. So after substituting the place of ZL power L minus 1, this form e power IL minus 1 5 sin theta whole power L minus 1, we would have this. So from this form we just get to this form. So we see the simplification. So e power L minus 1 5 we are having. So that has to be taken outside. So e power L minus 1 5 and e power minus I5. That is e power minus I into L minus 1 5 into e power minus I5. So already we would have e power minus IL minus e power I L minus 2, sorry, e power I into L minus 2. So actually we are having e power I into L minus 1 5 in the place of ZL power L minus 1. So e power L minus 1 5 into e power minus I5, we would have e power I into L minus 2 5 after simplification procedure. And sin theta power L minus 1 would remain as usual, and dou by dou theta would also be there like that. And next thing is here in the place sin theta whole power L minus 1 is there. So after replacing this with this, that is sin theta whole power L minus 1, again we would have, actually ZL power L minus 1 is here, we have already derived it. So in the place of ZL L minus 1, we need to substitute this thing, this entire equation. So ZL power L minus 1, if we substitute here, we are having e power I into L minus 1 5, here e power minus I5. So after simplification we would have e power I into L minus 2 5, and this sin theta whole power L minus 1 would remain as usual outside. So here, and next thing is here we are having 1 by sin theta whole power L. So 1 by sin, inside this already we are having 1 dou by dou theta. So that is this dou by dou theta, and into 1 by sin theta whole power L. 1 by sin theta whole power L we would have here. So here sin theta whole power L in the denominator, in the numerator sin theta whole power L minus 1. So it is of the form just like sin square theta by sin cube theta. So then we would have 1 by sin theta. In the same manner here also sin theta whole power L minus 1 divided by sin theta whole power L. So we would have 1 by sin theta. So that is that 1 by sin theta. And again this is taken out in the constant. So it is a constant. And another dou by dou theta sin theta whole power 2L. So again dou by dou theta sin theta whole power 12. So after replacing xi L whole power xi L minus 1 with this equation, if we substitute in the place of that this part, and after simplification if we do, so here already one dou by dou theta is there, that is dou by dou theta, and in this equation also if we take this both aside, another dou by dou theta is there, dou by dou theta sin theta whole power 12. So that is the thing, another dou by dou theta and again 1 by sin theta, again dou by dou theta sin theta to whole power 12. So why we are getting 1 by sin theta means here already sin theta whole power L minus 1 is there, and from here we are getting 1 by sin theta whole power L. So after cancellation 1 by sin theta. So this is the equation we would have finally. So this is the wave function for m value L, m is equals to L minus 2. So xi L minus 2 is a wave function is of this form. So again if we want to get for L minus 3, L minus 4, L minus 5 like that, so repeated application of Lx minus ILy would yield. So remaining wave functions also we could get by this procedure if we go on doing the same thing for different. So in this manner we can find the wave functions for different possible values of m and for the same value of L. So for a given value of L we have different possible m values. So all these are all, so this xi L power xi L L xi L L minus 1 xi L L minus 2, all these are all the wave functions for the same value of L but for the different values of m's, that is for L minus 2. So here you can see L L L for all of them L value is same, but only where the difference is m value, m here L minus 1, L minus 2. So repeatedly if we apply in this manner Lx minus ILy it would yield. So again if we apply for this equation in the same manner like this, if we go on keep on applying for s times, so it would yield equation of this form. So xi L minus 2 in the place of 2 L minus s. So actually we have applied 2 times here. So first from xi L we have shifted to, after one time application we have shifted to xi L minus 1. So again after another time application we have shifted to xi L minus 2. So number of times we have applied is 2. So xi L minus s in the place of 2, if we say replace it in common as s, and here e power I L minus 2 5. So here also 2, here also 2. So here also e power I into L minus s into 5. After applying for s times we would get this term. And next thing is here we are having L minus 1 but here it is L minus 2. So what we have to do, in order to get L minus 2, what we have to do here is into sin theta by sin theta into sin theta by sin theta. In the denominator we need to multiply with into sin theta by sin theta. So sin theta would be kept aside, and 1 by sin theta if we take into this side we would have sin theta into L minus 2. So hence we would have sin theta whole power L minus s, and another sin theta which we have kept aside would be taken here. So actually what is happening here is, if we keenly observe here, so this is sin theta whole power 2L, so this is also sin theta whole power 2L. So this form is this form as usual, and here what we are doing is differentiating this one with dou by dou theta, and again we are multiplying with that is 1 by sin theta, we are multiplying with 1 by sin theta. And next again what we are doing, again we are differentiating with dou by dou theta, and here after simplification as I said here into sin theta by sin theta. So one of the sin theta has gone here, so another sin theta is remaining here. So 1 by sin theta dou by dou theta. So already for this we are differentiating with respect to theta and multiplying with 1 by sin theta. Again the same procedure, dou by dou theta we are differentiating and multiplying with 1 by sin theta. So this procedure is for 2 times we are doing. For 2 time application of Lx minus ILy, 2 times we are doing the same procedure, dou by dou theta and multiplying with 1 by sin theta, dou by dou theta and another sin theta after simplification, because here we need to get L minus 2 because here L minus s is there. So 1 by sin theta. So hence we are having this form 1 by sin theta dou by dou theta whole power s. So for 2 times application we would have dou 1 by sin theta dou by dou theta whole square. And for s times applications we would have 1 by sin theta dou by dou theta whole power s. And this is sin theta whole power 2l. So the meaning of this part is nothing but sin theta whole power 2l is being differentiated with dou by dou theta, and again it is multiplied with 1 by sin theta, and again it is being differentiated with dou by dou theta, and again it is getting multiplied by 1 by sin theta, and again that part is being multiplied with dou by dou theta, and it is being multiplied 1 by sin theta. So this procedure continues for s times. Here also the same thing is happening. So here first of all we are differentiating sin theta whole power 12, and again we are multiplying it with 1 by sin theta, and that part the part which we have obtained after multiplication with 1 by sin theta, that part we are again differentiating with respect to theta, and again that part is getting multiplied with 1 by sin theta. So that is the meaning of this part of the equation. So this is the wave function. So these are the unnormalized wave functions of Lz and L square. So these are the unnormalized, they are not normalized. So because we know for normalized wave function integration of xi star d tau equals to 1. So unnormalized means integration of xi star d tau is not equal to 1. We would get some value, some a. So like that. So this is the wave function for m value is equals to L minus S. So in general, this is the form of the wave function. So these are the unnormalized wave functions of Lz and L square. So for these are all the wave functions of L square. This xi L, L, xi L, xi L minus 1 L, xi L minus 2 L, xi L minus S L. All of them are the wave functions of the L square, because eigenvalue of L square is L into L plus 1 h square. So these are all the wave functions for same value of L but different values of M. So for different values of M h cut, eigenvalue of Lz is nothing but M h cut. So this is the required wave function we needed to derive. So thank you.